Hello and welcome to this video, which is being created to help you through this week's laboratory activities that have to deal with radiometric dating. So to start with, hopefully you have already downloaded the assignment. If you haven't, you should do that now. I am going to share that on the screen with you. Okay, so here's the activity, and you'll see you can read through the learning objectives on your own. The first thing you're going to do is collect a bunch of data, okay? And for that, you're going to need a couple of different things. You're going to need to go to this web address. You might want to go ahead and type or copy and paste that in right now. And you're also going to need, if you scroll down, you're going to need this sheet, okay? So you have multiple options here. If you are working on the Word version, you ought to be able to click in and edit this as needed. If you have a stylus and have an easy way to draw on the PDF, I recommend that. That's probably the easiest. Or if you have access to the printer, you can go ahead and print out the full lab, fill it out regular way with a pen or pencil, and then upload it once you're done just by taking a photograph with your cameras. Okay, so let's read the directions here. You're going to go to this link, and you want to set up 50 dice that are going to represent 50 different atoms of our parent element, which we are calling Greyhoundium, right? Greyhoundium. The daughter element is called Studentium, okay? So 50 atoms. Let's go ahead and do that. I can figure it out. There we go. Okay, so the default, at least when I pulled it up, was 2. I'm going to go ahead and change that to 50. So these 50 dice are going to represent my 50 atoms of the element Greyhoundium, the parent element. I'm going to roll them, and now every time I see a 1, those 1s represent atoms that have radiometrically decayed into Studentium. So let's see how many 1s there are. I am seeing 1, 2, 3, 4, 5, 6, 7, 8. 8 atoms of Studentium. So the next thing to do, let's see. Go back to my activity. Go. And I hope I said 8. Doesn't like anymore. Oh, I'm in the wrong version here. Hold on. Close that. Oh. Here we go. Back on track. So I removed 8. Die, so that's 8 daughter. That leaves me with 42 of my parent. And the percent parent, well, that's going to be whatever 42 divided by 50 is. I'm going to pull out my calculator. And 42 divided by 50 equals 0.84. So I have 0.84 or just 4%. 84 is the number that you're looking for there. Okay, now we're going to do the same thing again, except this time we don't want to re-roll any atoms that have already decayed, right? This is now a stable product. So the only ones that we want to allow for another half-life to happen are going to allow for another bit of time to pass is going to be our Greyhoundium. So if we go back to our dice, okay, we rolled 50 dice, but now we need to only roll 42 dice the next time. So if we go back, we can change this to 42 and roll dice. Now we again count the number of ones. All the ones represent Studentium, and we will take them out of our sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, okay. So we go back to our other sheet. And we write in that 11, which now 42 minus 11 is going to be 31 parent remaining. And the percent is still going to be the percentage out of the original. So this is going to be 31 divided by 50, which is going to be 31 divided by 50 in the calculator, 62%. 62. So I don't need to actually write down the 31 divided by 50. That was just as a note. What I need to write down is 62. 62% of the parent remains, and the rest is daughter. Now you're going to just continue doing that, sort of digitally removing the atoms that have decayed from the total sample and figuring out how much parent you have left. So go ahead and finish that exercise, and I'll be right back with you.